This presentation is on decision properties of context-free languages. We will explore decidable and undecidable problems specifically for context-free languages, within the broader scope of the theory of computation. Let's define decision problems. These are problems that can be framed as asking a yes or no question about formal languages and their properties. For example, asking whether a language L is empty, asking whether a string W is a member of language L, or asking whether two languages are equal are all examples of decision problems. Here we discuss the difference between decidable and undecidable problems. A problem is decidable if an algorithm exists that always terminates with a yes or no answer for any input. On the other hand, a problem is undecidable if no algorithm can solve the problem for all possible inputs, meaning the algorithm might run forever or give an incorrect answer. Let's explore decidable problems for context-free languages. These are problems that we can solve algorithmically. First, the membership problem, determining whether a string W belongs to the language generated by a context-free grammar G, denoted as L of G. Second, the emptiness problem, determining whether the language generated by a context-free grammar G is empty, which means L of G is equal to the empty set. Here's how to solve the membership problem using the Cock-Younger-Kasami, also known as CYK algorithm. The algorithm first converts the given grammar to Chomsky normal form or CNF. It then builds a CYK table and fills it bottom up. Finally, it checks if the start symbol is present in the top cell of the table. The time complexity of this algorithm is order of n cubed multiplied by the size of G, where n is the length of the input string and G is the grammar. This algorithm works specifically with grammars in Chomsky normal form and uses a dynamic programming approach. The emptiness problem asks whether L of G equals the empty set or not. The algorithm to solve this involves finding all variables that can generate terminal strings using reachability analysis. The complexity of this algorithm is order of the size of G. Let's explore undecidable problems for context-free languages. These are problems for which no algorithm exists that can always provide a correct yes or no answer. First, the equivalence problem, determining whether the language generated by context-free grammar G1 is equal to the language generated by context-free grammar G2, or whether L of G1 equals L of G2. Second, the universality problem, determining whether the language generated by a context-free grammar G is equal to the set of all possible strings over the alphabet, or whether L of G equals sigma star. Here's a summary of what we have discussed. For context-free languages, the membership problem and the emptiness problem are decidable. However, the equivalence problem and the universality problem are undecidable. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.